Hi everybody, I have for you today your semester 2 unit 2 review. And this is going to go over basic concepts in unit 2, and then throughout it I will be completing problems related to the unit 2 review guide assignment, which I think is worth like 35 points. Okay, so in the first unit we were all about factoring. Today we're going to be talking all about solving quadratic equation. A quadratic equation is anything that has an x squared value in it. So if you remember from unit 1 where we had x squared plus, 4x plus 4, and we learned to factor that. That was unit 1. Lots of you have finished the unit 1 test. Great job, and have done outstandingly. That's awesome. Now we're going to talk about how to solve that. So instead of just factoring it, we're going to start talking about finding x, just like you did back in, probably middle school where you solve for x, except the difference is we have this x squared value. So there's going to be 2 answers. And so there's lots of options and lots of ways to solve quadratic equations, just like there were lots of options for factoring. And we are going to be going through all of those ways, and each lesson talks about different ways to solve from there. Okay, so probably the first one, and the most important one, and the one that is used more often than not, is the zero product property. Okay, and what does the zero property say? Zero product property. It's kind of a tongue twister. It says if you get the equation in standard form and set it equal to 0. So in order to use the zero product, it's got to be equal to 0. I think that comes up in a couple of assignments. But you can't use this method unless you set it equal to 0. Standard form, remember, is going to be ax squared plus bx plus c. Now, again, these could change, this plus here and this plus here. But a, b, and c are coefficients we're going to be talking about throughout this whole unit, so you want to make sure you know those. So you get it in standard form, write it in that form, and then you factor it if possible. Can't use zero product property if it's not factorable. But if it's factorable, then you can set that to 0. And if these two things multiplied together equal 0, then that means this one has to equal 0 or this one has to equal 0. One of them has to be equal to 0 because way back when you first learned multiplication, you learned anything times 0 is 0. So if my whole product is 0, that means that one of the items has to be a 0. Okay, so once you get it factored, you write 2 different equations, one-step, pretty simple equations. They could be a simple 2-step equation, as we'll see. And so that means that x either has to be 11, that's one of my solutions, or -2. Because either one of those, when I plug it in, will give me something equal to 0. And that gives me my 2 solutions. So let's try one here on this equation here. We're going to factor it. First of all, it is in standard form. It's set equal to 0, so now I can factor it. I chose this one because it was a little bit more challenging one to factor. Ultimately, I know I've got to have a 3, so that means the only options there are 3x and 1x, and often I don't write 1x. I'm just doing that to help you see that. 7 is also prime in that the only factors of 7 are 1 and 7. So what we got to think about here is the fact that it's negative. That means one of these needs to be plus and one of them needs to be negative. So I can write a plus here and I can write a minus here and I can write 7 and 1 and I can check it. So that would give me 3x. That would give me -7. But when I check this one, I would get a positive 1x here and a negative 10x. So that does not give me my middle term. So again, I can try again. I know I've got to have 3x and I've got to have x. And I didn't like having the 7 and the 1, so let's put the 7 here and the 1 here. And again, one of them has to be negative, one of them has to be positive, and I want a -4x as my term. So I'm going to make this negative here. That'd give me -7x plus 1 there. If I check this with FOIL from last unit, I would get 3x squared for the first terms. And for the inner terms, I would get negative 7x, and I would get plus 3x, and negative 7 plus 3x would give me negative 4x, so that checks, and then I would get a minus 7. I'm going to set that equal to 0 because I'm using the 0 property. That means I have two simple equations, 3x minus 7 equals 0, and x plus 1 equals 0. And so then I'm going to solve this basic equation back to, like I said, probably 7th and 8th grade. Add 7 to both sides. 3x equals 7, divide by 3. X could be 7/3, and as you see over here, I've got a 7/3 here. It's not going to be negative 7/3, so I can cross those out. So it's got to be one of these answers, and then the question is it positive 1 or negative 1? Well, when I solve this one, I get x equals negative 1, so I want the solution where x is 7/3 and x is negative 1. All right, question. The next question involves factoring the same here. I'm going to make sure I've got my volume all the way up on this video. Very good. And so whenever you get one of these word problems, width of a rectangle, length, first thing you should do is sketch this. The width of the rectangle is more than the length, so I'm going to sketch a picture here. Here's my length, L. Make sure that looks like an L. And my width is longer, so I'm going to draw it bigger. And this is my width. And then it says the width is 2 more than the length. So I'm going to not use W. I'm going to do L plus 2. So I have L and L plus 2. The area of the rectangle is 63. So if you remember that area equals length times width, I'm going to have L times L plus 2. And that equals 63. Now, I hate having it written backwards, so I'm going to finalize it here. I'm going to distribute this out and set up a neater equation here. L squared plus 2L equals 63. Now, remember, if I'm going to solve this with factoring in the 0 product property, I got to move 63 over. Has to be equal to 0. So I subtract the 63 from both sides. Equals 0, and this factors very nicely. 63 has two factors that are different by 2. That would be x, it would be 7 and 9, and I want the 2L to be positive, so that's going to be x plus 9 and x minus 7. Now, when I go to solve this one, because it's a real-world problem, I get two answers. I get x equals negative 9, and if you don't know how I jump to that, it's x plus 9 equals 0, minus 9 from both sides. And then I get x equals 7. But since we're talking length, x plus 9 is what we call an extraneous root. It's not one that works for a real-world problem. You cannot have a length being not a negative number. So that means this would be x is positive 7. I apologize, because when I add 7 to both sides. So that means my length is 7. And length plus 2 would be 9. The width would be 9 inches. 9 inches. Moving on to solving quadratics by taking square roots. You can take square roots of items. These are straight out of your lesson, so I hope you're watching the lesson. But what they're showing you here is that if you can get both sides, if you can get down to where you have no middle term. Okay, so I don't want a middle term in between there. So here, by adding 5 to both sides, I get x squared and 32, and then it has you working on simplifying roots that we learned in Unit 1. So that would be one option. Whenever you take the square root of a side, you make sure that you do this plus minus thing, because when I take the square root of 9, that could be 3 squared, or it could be negative 3 squared, and that's why there are two options, the plus and the minus of 3. In example 2, I have a quantity squared here, so if I add 1 to both sides, then I get x plus 2 equals 8, and I can take the square root of 8, and I get square root of that. This would be plus or minus the square root of 8, and then I would subtract 2, and I can take the square root of 8 and simplify it. That would be 4 and 2, and the 4 would break out. That's how you end up with this final answer. Okay, so let's do a couple of these together. Sometimes these are harder to see. Okay, so solve this equation by taking the square roots is what they're asking you to do right here. First thing I'm going to do in this equation is I'm going to take out a GCF right here. So I'm going to divide this side by -2 and this side by -2, which is going to give me this new equation of x plus 1 squared minus 8 still equals 0, because 0 divided by -2 is 0 divided by a -2 is still 0. Now, if I take this -8 and I move it over, then I would have just a simple squared term over here and something I could take the square root of. So I'm going to add 8 to both sides, which is going to give me x plus 1 equals, or x plus 1, sorry, squared equals 8. And now I have a scenario where I have something I can take the square root of on both sides. I can square root this side and get x plus 1. The square term would cancel. And what I do to one side, I have to do to the other. So that's going to leave me with plus or minus the square root of 8. To get x by itself, I would subtract 1 from both sides. Can't put those together because they're not like terms. So my equation would be -1 plus or minus the square root of 8. And when I look over here, you might say, Ms. Kearns, there's no -1s. They have all these weird numbers. Okay, well, I know it's not +1. So it could be this one or this one. It's not square root of 14, so it has to be this one. Why is it written 2 square root of 2? Because 8, as we just saw in the last slide, can be broken down to 2 radical 2. So my answers would be -1 plus or minus. So here I have the -1 plus 2 square root of 2. And here I have the -1 minus square root of 2. 2 square root of 2. Again, solve this one by completing the square. So what this is having you do is it's having you create a statement like this that you can take the square root of. So to complete the square, first thing you got to do is you got to get rid of this guy, move him over. So we have x squared plus 10x equals 3, because I added 3 to both sides. Now, what would I have to add to this number so that I could write it as x plus something squared, right? And if I do that, that's what I'm trying to do. I'm trying to get to a situation like that. And whatever I add here, I will then add to this side, and that way I can take the square root of them. So how you figure this out is you take half of this number, and then you square that number. So 10 divided by 2 is 5, and 5 squared is 25. So I'm going to add 25 to the left and add 25 to the right. And that number you add is always determined by the middle term here. If that had been a 4, I would have taken half of 4, which would have been 2, and squared it. If that number had been 20, I would have taken half of 20, which is 10, and squared it. And that's the number you're going to add. So my new equation, let me erase this part right here so I have some room. My new equation that I can create so that I have a perfect square is x squared plus 10x plus 25 equals 28. And then I can take this perfect square trinomial and write it as x plus 5 squared, that's what that equals 28. And now I can do square rooting to solve. It's like adding some things. You add some things to make the problem easier. So I get x plus 5 equals plus or minus the square root of 28. And then I get x, subtract 5 from both sides. X equals -5 plus or minus the square root of 28. And again, we start looking through here. -5, so it's got to be this one or this one. And again, none of them have, none of them have 28. So then you got to say, oh, does 28 simplify? And sure enough, it does. There's a 4 in there. 4 times 7. 4 comes out as 2 radical 7. So -5 plus or minus the square root, or plus or minus 2 square root of 7. So -5 plus 2 square root of 7 minus 2 square root of 7 gets me my correct answer there. Solving the quadratic function, or quadratics using the quadratic formula. This is something you want to have in front of you for your unit test. You want to have it in front of you for the final exam. You need to know what the quadratic formula is and how it works. Anytime you have an equation in this form, ax squared plus bx plus c equals 0, this is a quadratic equation. this A is a coefficient, B is a coefficient, and C is a coefficient. And it's talking about these values here in this equation, telling you what X value would be to make that work, to solve it. X would be this number, and then you can plug it back in to figure out the Y, and that was how I would get to that 0 value. Okay, one thing I want to draw your attention to is it says the opposite of B. So right here, it's always written ax squared plus b. If this is a minus, that means you have a negative b value. In this formula, it would become positive then. If it's a plus right here, it would be negative, and I'll show you a couple of those things. So solve this using the quadratic formula. First thing you got to notice, this isn't equal to 0. So I need to move this over here. So I have 5x minus 18 x minus 8 equals 0. And then if I'm going to use the quadratic formula, and if you don't like factoring, or if you have something that is prime and it cannot be factored with real numbers, this is your only option. Okay, so again, I hope you wrote that down in your notes. It is the opposite of b. Try to find where I wrote it on mine. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so here we go. The opposite of b, that is going to be, b is negative 18. Sometimes, especially when you're first learning, it might help you to write out what things are. A is 5, b is negative 18, and c is negative 8. This will keep you from losing signs in the process. So you're going to have 18 plus or minus the square root of b squared, which would be negative 18 times negative 18, which is 324, plus, not plus, it's going to be minus 4 times 5 times negative 8, all over 2 times 5. And then you're going to calculate this. A lot of people struggle with this portion under the square root. I always tell kids to look for a negative here. If you have one negative sign here, that's going to make this whole thing plus. So my next layer would be 18 plus or minus square root of 324 plus 160. Because 4 times 2 times 5 times 8 is 160. And it would be negative 160, but minus negative 160 is plus. Over 10. And then that is going to be written as 18 plus or minus the square root of 44 over 10, which is 18 plus or minus 22. No, not 22. Oh, yeah, 22, sorry, over 10. So 18 plus 22 over 10, and 18 minus 22 over 10. And this is what our x's will equal. We're figuring out the x value. And so if you notice here, we're looking for the x's that equals. So 18 plus 22 is 40. I'm out of space here, so hopefully you can follow along. This would be 40 over 10, which would be 4. And this would be negative 4 over 10, which would reduce to negative 2/5. So I'm looking for 4 and negative 2/5. So here's a positive 4. That one's out. That one's out. And I'm looking for a negative 2/5. Looks like it's the top answer here on question 9. All right, next we get to graphing quadratics. And one thing you want to understand is that anytime you have an x squared in your equation, the graph is going to be this shape, sometimes up, sometimes down. It's called a parabola. You can have skinny parabolas. You can have really fat ones. Various things. We're going to learn all kinds of things about graphing. But in the lesson, eventually, you get to some Desmos calculator information and things. I would definitely recommend looking at that and using that. Those can be very helpful. So this is in a quadratic equation right here. This value right here, you definitely want to have this on your reference sheet. And this is the value of what we call the vertex. And the vertex, and when I'm teaching this in school, I like to call it the turning point. Okay, and that turning point can be at the top or at the bottom. but it's the very point where the shape changes, and instead of continuing on a downward path, it becomes up. And so there's lots of variations, lots of applications. You're going to have some real world problems. I know you're going to hate them, but you talk about like shooting basketball, you know, from here it goes up and it comes down. Or you talk about throwing a football. A football throw is not quite as drastic, but throw a football that way. You can have things that, you know, go down and then come back up, right? Something that you drop and it bounces up, it's going to have that shape. But that point where the direction changes is called the vertex. And this is how you find the value. That vertex is the lowest spot, or it's the highest spot, depending on the application. Okay, so when they talk to you about what's the highest point of this, what's the lowest point, people are like, I don't know how to find it. They're asking you to find the vertex. And if you plug in those B and A values there, you can find out what X is. And then if you know X, you can plug it in to find Y. So finding the vertex here. Again, the formula for the vertex is, I'll keep going through my notes here that I wrote down, hopefully like you're writing down, X equals negative B over 2A. So in this equation, A is 2, B is negative 4, and C is negative 5. Okay? So we've got X equals, the opposite of negative 4 would be 4, over 2 times A, which would be 2 times 2, which means my X value is 1. So can't be this one, can't be this one. How do I find the actual vertex? That is the X value, so I'm going to plug it in, and I'm going to have 2 times 1 squared minus 4 times 1 minus 5, 2 minus 4 minus 5, negative 2 minus 5 is going to give me negative 7. So that point of turn in this equation is going to be 1, negative 7. This X value is also called the axis of symmetry. Okay, so if you think about this 1, 7 on a graph right here, here would be 1, way up here somewhere would be 7, and that's where this would be turning. Actually, this one would be going up, so that's where it'd be going like this. And that point where it turns is also the axis of symmetry value. And so it's always an X equals equation. And that's what you would be looking at there. Right? So when it says find the axis of symmetry and the y-intercept, we have the same equation. If you look here on 13 and 16, exact same equation. So we know that X is 1. We know the vertex. Sorry about that. Hang on just a second. I need to tell them I'll call them back. So we know that X is 1. So we're going to have, plug in the 1. We got X, we got the ordered pair of 1, negative 7. This value then is the line where that would be bending as an axis of symmetry right here. Okay, so that would be the first one, choosing 2. And then the y-intercept is whenever X equals 0. So I'm going to plug in 0 here. I would have 2 times 0 squared minus 4 times 0 minus 5. That's going to be 0 minus 5. The y-intercept, much like in the linear situation, is when everything is X is 0. Cross everything out. This all gets crossed out. It would be at 0, negative 5. That's question 16. And then the last thing, it kind of all comes together talking about understanding the roots and the zeros and all of those things. Notice this is straight from the screen. They're showing you what that parabola looks like. Here we have the vertex. X-axis at 2 and negative 6. That's where it's crossing. Those are called the zeros. They're also called the roots, and you have a little bit of an explanation here, right? If I factor this, I get this. So the roots and solutions are X is 6 and X is 2. So roots, solutions are kind of interchangeable terms for the same thing. The zeros are from the function of this. That's where those are at again. So zeros, roots, and functions. And there are some times where you don't have real values because it's not factorable, so it's prime. So you have to use a quadratic equation, and then you still can have those zeros, but there's no real roots. They would be irrational root values, and we'll look at some of those in the next slide, I believe. So when you get to this equation right here, and it says find the roots, that means you should factor it. The problem with this one is when I go to factor x squared minus x plus 24, that means I would have to have a minus and a minus because I want this to be the same, and those are negatives. That's from Unit 1. When I go to solve this equation like this, I am stuck with what are my options for 24? Well, I have 1 and 24, but that doesn't give me a negative 1. I have 2 and 12, but that doesn't give me a negative. That gives me negative 14. I have 3 and 8, which gives me a negative 11. I have 4 and 6, which would give me negative 10. There is no possible way to get this factored. So my only option to factor this would be the quadratic formula. And if I do the quadratic formula, that means it doesn't have any real roots. It would have irrational roots. So my answer to number 28 is going to be no real roots, because I would have to have that negative b plus or minus the square root of b squared, which I could do, but I would get an answer with a square root in it, which means it would be an irrational number and not a root. Okay? So that pretty much wraps up Unit 2. I'm sorry I didn't get this out to you sooner. I will be working on the Unit 3 video and posting that in the next day or so. Keep working hard. Looking forward to hearing from you. And let me know if you need any assistance.